Boop. Thanks for the reminder, guys. All right. So operations with complex numbers. So we're going to talk about what we can and can't do with complex numbers, or more importantly, how we do it. So just like variables, we have to have like terms. So with variables, we have to like organize them and stuff like that. It's going to be the same thing with complex numbers. Think of the I as like a different type of variable. So when we're adding and multiplying, all the properties from before still work. You can add them in any order using the associative property. Same thing with multiplication. You can multiply them in any order. You can add them backwards and multiply them backwards. And you can distribute. Distributive property work. All of this works with complex numbers. So if we're looking at this, what they're doing here is if we want to solve for y and x, usually, they haven't even talked about this yet. That's weird. Watch, they're going to talk about it later because Edmentum hates me and it can't be normal. Usually when we're graphing, there's a graph of complex numbers. So the graph of complex numbers has the real numbers on the x-axis and the imaginary numbers on the y-axis. So that's what come to usually associate your y and x's together. So when we're looking at this, oh, they're not even talking about that right now. They're literally just saying that you can just add them in any order. Never mind. Okay, Edmentum, you are normal. Then we have this one. So it's just saying any for associative property, we can do it in any order. So it's basically all the same stuff. They're just giving you visual aid on it. I don't know why they're doing it again, but that's cool that they're being that thorough. So with this one, we're going to get rid of the parentheses and just add them together. So in this case, we're going to get 9i and 7 because we're combining that 3 and that 2. So that just makes it nice and easy. I don't know why they're doing it one step at a time, but there you go. So just group them together like terms. Same thing as with regular variables. More importantly, when we get to the multiplication, that one makes a little more sense. So if we were to add this one, we're going to add the 6 and the 10 together. And they want it in complex form, the standard form for complex numbers. So always put your real first and then your imaginary number second. All right, and then, so if we're doing this, we're going to add these two complex numbers. So we would get 16 plus 9i. Perfect. And then they show the steps here. Unfortunately, Edmentum doesn't like us showing our work because I've done it before where I type in all the work and it doesn't let me. On your activities, though, please make sure you're showing your steps. One of the reasons, too, that I make you guys show your steps on the activities is if you get like a lot of wrong answers, I look at your work to be like, okay, so they know what they're doing. They just messed up on this one step. So another one is the distributive property, specifically with negatives they're showing here. If we distribute it to both. So usually we want to get rid of our negatives by just distributing. So it's just saying that right here. So let's say we're subtracting this. We're subtracting the entire number. I don't know why they're not showing the parentheses, but usually you want to put these in parentheses if they mean that. I don't know why they're doing it that way, but distribute first. And then after you distribute, then you can combine your imaginary and your real numbers. So from there, it's pretty simple. You just combine them 8 and 3, take away that is 2. And this negative turns into positive because the negative times the negative is a positive. So here we're going to show it for all of this, so we distribute. So this makes it -6, which would make it a 1 in the real numbers, and it's going to make it a +4, which makes it a 1 for the imaginary. So 1 and I. Next one, we're going to distribute again. So we have a -6 because it gets distributed. So we have a -2 as the real number. They don't even try that hard. It's just right there. Then we're going to distribute this negative, so we get a +1. Oh, I guess in this one they did try a little bit. A negative and a negative makes a positive, so 5 plus 4 is going to be this 9. Oh, shoot. Thank you, Brianna. I did forget about the daily question. The daily question is, what do you find you are enjoying more after the COVID pandemic, or what do you enjoy doing during this time? So if there's not anything that you enjoy doing more, make talk about something that you find yourself doing or enjoying while you're doing it. Mine is kind of because I'm fat. I enjoy the curbside pickup. Basically, I like being able to just be like, I already know that I want like a double cheeseburger, and I can just put it in there on the order, drive up, hit the button, they open the door, they give me my food. I don't have to wait through a line or anything. Being lazy for 48 hours. Isn't that called the weekend, Nelson? You call that Monday and Tuesday? Wait, we have Algebra 2 class on Tuesday. You put the thing on mute right away. Carter, there's only 24 hours in a day. How can you be lazy for 48 hours in one day? That's a whole new level of lazy. All right, so hold up. Now I forgot where we were at. But thanks, Brianna. I did forget about the attendance question. There we go. All right. And I'm sure you had that up earlier. I just forgot to look over. All right. So this next one, we're going to distribute the negative. So we have 9 negatives. If you guys are still having trouble with like positives and negatives, I still do this sometimes just to remind myself. I like thinking about like, oh, there's a lot of negatives and there's a little bit of positives. So I know that my 5 negatives are going to cancel out with 5 negatives. So I'm left with 4 negatives. Boop. I know that was a little weird to go, but just a reminder, if you guys are still having trouble with negatives, that's kind of like an easy way to think about it. All right, distributive property. So when we distribute to everything, including i's. If we're saying that this entire thing is an I, that means it's di and ei. And I mean, that's kind of basic because if we think about it like this, it would be saying this 3i plus 2i, right? Or we can think of it as 5i, which 3i plus 2i is also 5i. So it's just saying like, hey, you can still do the distributive property. So complex numbers with the operations aren't that bad. I feel like they got into more of the complex. The more of the complex stuff comes with the multiplying of the i's. So here it's like, can you use the distributive property? And then we're going to recall how to do it here. So, okay. So here, when we distribute, we get 6x times 3. So we have 18x. And then we're going to have 6 times 2. So that's a positive. 2x. Use our little superscript button. I didn't know that there was a superscript button right here. This whole time I've been using the equation editor to do my exponents. So that's what we get there. If we're doing this with I, what we would end up doing is same thing. They literally give you the same example, but the I squared. That makes it a little different. So we get 18I plus 12I squared because it's I times I. But this I squared is the same thing as 1. They're reminding you that I squared is the same thing as -1. So from here, get rid of my superscript. This is going to equal 18I plus 21 times -1, which is the same thing as 18I minus 12. And I know this is a little repetitive, but they do want you to have it in the correct form. But we just switch them over. So by using the communicative property, again, I don't want you guys necessarily memorizing that. Just know what you can do with it. Like if you guys know what it is, but you don't know what it's called, you just like, I know I can switch these. I don't know why. That's fine. You only really need those when you're doing proofs, and we don't really do proofs in Algebra 2. So our answer would be -12 plus 18I, because we always want to get rid of our exponents with i's. There's just no purpose of having exponents with i's. You might as well reduce it to either I, -1, -I, or regular +1. And then, oh, they showed the steps going down. Oh, and then they put them in order. I forgot to put these in order. But there you go. All right. So let's get down to this one. So FOIL method still works. One of the things I learned later, I didn't teach this for my first algebra class. So Nelson, I'm sorry, I learned this later. I learned this for Sammy's algebra class. FOIL actually shows up here. So if we do A, B, or actually, I think they have it like this. A plus B times C plus D. What happens here is we're going to do first AC. So this is our F for FOIL. And then this next one, we're going to do last. Last is going to, I'm sorry, this is first. So we do first outer. So now we're going to do outer, A times D. So A times D, that's this one right here. AD. And then we're going to do inner. Inner is B times C, which is right here. Oh, I should have used the colors they did. Now I'm going to use the colors they did. So first was in red. So I'm going to do that in red, which is AC. And then I'm going to do outer FOIL. And then last is L. And inner is I. Okay, there we go. Yay, it's all fun colored. So we can do the box method by doing it this way. First, outer, inner, last. So I like the box method. It you don't have to memorize the FOIL. It's literally just do what you have to do. But I'm going to show how it correlates, how FOIL is the exact same thing as multiplying by the box method. So A times D is A times D is outer. So I'm going to do that in green. Then I'm going to do inner, which is the inside. So that's going to be this BC. And then I'm going to do last, which is this BD. So FOIL or box method, you can do both ways to multiply them. All right. So they're using FOIL. Again, you can do this with the box method also if you guys like the box method. I recommend it. It just makes things easier. So if I did this by the box method, it would still work. 2 minus negative 5i, and then 7, 3i. 7 times 2 is 14. 6 times 3i is 6i. Negative 5 times 7 is negative 35i. Negative 5 times negative 5i times 3i is negative 15i squared. Now this I squared turns it into a positive 15 because I squared is a negative. So we get that positive 15 right there. We get the 14 in the front. We get this negative 35i plus this 6i. So we end up getting, we're going to combine our real numbers and we're going to combine our imaginary numbers. So what's going to happen here is we get this 29 plus, is that also 29i? Yep. Oh, but it's negative. We have more negatives than positive. So that way you can see that this FOIL method does the exact same thing as this box method. So either way you guys prefer. I've met people that exclusively use the box method for multiplying and factoring, and it's pretty useful. All right, so let's do complex numbers. How are we going to solve this? So first of all, we have to get rid of these negatives. So we're going to pull out those negatives. Oh, they skipped steps. They went from like, I'm going to show every detail to I'm going to skip it. So we take out the I. Square root of 16 is just 4, so 4i. We're going to take out the I. Square root of 4 is 2. Then we have to square this first. We have to do our exponents before we do our FOIL. So that's what they did here. And then they're going to FOIL this. And then they're going to do this one. Now, if you guys have trouble with this, just remember, get rid of your I squareds first. So it doesn't end up being that bad because you're only going to be left with a binomial. It's impossible for you guys to be left with anything except the binomial. Because let's say, for example, you have this. This is just going to be b minus a minus b, which is going to be its own number. Or if you have something like a plus bi plus di plus di squared, this would end up turning into one number itself. This I squared turns into a negative. And then we're going to have this plus b plus c I. So it's still going to be a binomial. And they're going to show that right now. They converted this I squared to a negative. They combined these two middle numbers. And now we have this. But if we go into the next step, did they just stop? They just stopped. Oh, I guess they continue it on over here. So they're continuing it here. So now we can simplify these two. We get that negative 12, negative 16. Now we can do FOIL again or the box method, whatever you prefer. Again, if you did the box method, you would get the exact same result. And you can even do it backwards, which I'm going to show you right now. So this is going to be 36. This is going to be negative 24i. Actually, in fact, if you do it backwards, I guess it's better because it does it in the same order going this way. This one would be negative times a negative is a positive. And if you do it this way, it's negative 32 I squared. So notice how all of these numbers are the same as all of these numbers when they FOILed it. And then as we keep going, we're going to change that. We're going to simplify these two. And now we can finally combine this. This turns into positive because it's a negative times negative. And we're left with a binomial. So even though we started off with a really, really big problem at the beginning, complicated looking, it ended up just being really simple towards the end. All right, so let's do some practicing with adding and subtracting. So which two complex numbers added together? So this one, it's literally just multiple choice. So we're gonna try to combine letters together. So we need to get 10. Okay, so if I want to get 10, I want to, let's see what we have here. If you guys see it, just type it in the chat. That way it's not just me looking at random stuff. I see that C plus A gives me 10. Oh, -3. Oh, okay, cool. So I get this A plus C would give me that 10. Because if I wanted to, I can just copy this, which is what I usually do. Ooh, copy the whole cell. I didn't want it to copy the whole cell. And then I'm going to add it to my C. This is just nice for me to see because then I can see which ones you're talking about. All right, and then the next one says when we subtract from each other. Ooh. So when we subtract from each other, another complex number from the table. Okay, so we want another number from the table. So in other words, they want something like, and this isn't true, I'm just making this up. If I do like A minus B equals C or something like that. So when I'm doing these, all right, so if I combine these negatives together, well, that won't work because that's going to give me a positive. So let's see what I can do here. Let's see. If I subtract, that'll make this a positive. So 17, that won't work. -15. Oh, -7 minus 8 makes -15. -6 minus 8, that'll be 2. That won't work. 6. 6, 6, 6. 5. 13 take away 8 is 5. If anybody sees one, let me know. I'm thinking this 15 goes in here somewhere. Okay. That's 10. That won't work. Is there 2 to make the 6 into that? No. So 3 and 7, that could make 7. This can make 3 and -7. If we're subtracting, that could make a +4, or it could end up making, oh, it just makes +4. And if we do -7 minus 13, we can either get 20 or -13 minus 7 could give us positive. Oh, this combined with this, does it give us that? So negative. Okay, so I'm doing C minus B. Does that give me H? So let me try this out. C minus B. Oh, wait, no, it has to be negative. No, that doesn't work because this is a positive. Trick me. So 13 minus -7 makes 20. That doesn't work. -7 minus 13 gives me -20. And that won't work either. 13 minus -9 is 22. That's not going to work. And if I do it backwards, it's going to be -22. -9 minus 13 equals -22. So that doesn't work. Anybody see it? Am I missing something? This is 4. That would be 21. Okay, I'm just going to do all of them together. Going to start one at a time. This would be 10, or actually 4. That would be 4, either plus or minus 4. This would be 10. Nope. This would be 3, take away 9. I get 6. Let me try that one. -3 take away -9 equals 6, and -4i take away 6 equals 10i. Yes, I got one, guys. It only took forever. So a minus d equals h. Because if we do that, -3 minus -9, we get 6. And if we do that, -4 minus 6, because we're distributing the negative, it turns into -6. We're going to end up getting that. Okay. So that took forever. So I'm going to say that my answer is A take away D equals H. So this one you do have to show a little more work. We can do it like how I did it. -3 minus minus 9. I'm grouping them together at the same time as I'm distributing. So I'm doing 2 steps at once, but it's just because I took forever doing it the first time. So I just kind of want to rush through it now. If you guys are fast using your keyboard, I recommend using your shortcuts. I usually do this. I just use my entire keyboard just to copy and paste everything. If you were wondering how I highlighted the shift and arrows, which of the following complex number multiplied with b? Okay, so they're making it a little easier. Gives us this product. So in other words, we're going to take this and divide it by whatever b is. What's b? B is -7 and -6i. So -7 minus 6i. Wait, what? Yeah, that's what it is. Which complex number would result in this? Which complex number from the table multiplied with b would give us that? How can I turn 6 into 27? Oh, there. I forgot. Because we're going to be multiplying by a complex number, there's going to be a lot more than that. Okay. So I want something that's going to involve this 7 that's going to get these i's together. Okay. So I'm looking at B, and I want to get 159 plus 27i. All right. So this one does take a little bit more work. You can't just divide it like I was doing. The reason being is I was not taking into account the I squareds canceling out. So the way I would think about this is, let's do this. -6i times something else. If I look at it in the sense of FOIL, this is going to be an I, and this is going to be an I. I used to call this the rainbow method when I would teach privately, because it kind of makes this upside down rainbow. Or I guess you could make it a regular rainbow like this. These these are going to be your eyes. So we want to find something that negative 6i times something else, and then this negative 7 times the imaginary number over there is going to give us something. So I'm just going to try plugging stuff in. So I want to get this 27 from this one. All right, so how can I get 27? I'm going to try it with something small. I'm going to try it with this. So if I do that, I'm going to get this positive 18i. And when I do it this way, I'm going to get this positive 28i. That's way too big. So I need something smaller. Or I need stuff to cancel out. So I know it's not A. I know it's not B because they wouldn't do that. I don't think it's going to be this one. Because if it's this, we get a really big number. That's way bigger than 27. Plus, think about it. This is going to make a negative number, and this will also make a negative number. And this is a positive 27. So that can't do. That won't work at all. So going down the line, now I'm going to do negative 9 and positive 6i. Well, this would make positive 72i, and it's going to make negative 48i. Let's see what my calculator says about that. Before, close, really close. I'm supposed to get 27, right? Okay. This is just one method. Feel free to let me know if there's other methods you guys think would be better to solving this. But okay, so I eliminated D. Now I have to try E. And like I said, the reason why this works is this is going to be a real number. Real times a negative is or real times an imaginary is an imaginary. A real times an imaginary is still an imaginary. So these are the only combinations. This inner and last are the only ways that'll do this. All right, so let's take a look here. I already did the 9. Let's try the 8. So this is going to be negative 48. And this over here is going to be positive 56, which would just give us 8. So that won't work. Then we're going to try 15. I feel like that's too big, but it's worth a try. Negative 15 plus 9i. This is going to give us... Ooh, I don't know why my mind went blank. 90. Duh. Because 6 times 5 is 30, plus 60 is 90. And then if we multiply those, it's going to be negative 63. Oh, we got it. We got it, guys. What letter was this? F. So BF equals that. So B times F. Where's my multiplication sign? I'll just put an asterisk. BF equals 159, 27. I'll do the rest just to kind of prove my theorem. Or actually, I don't even have to do that. I can show you guys the sample answer. So what's happening here is as we do FOIL, this gets to 150. These two, see my middle terms? This was my rainbow method, basically. This was my last, or my outer and my inner. Outer and inner. Because this one, the I squared would always make a negative 1. So that's how come I was like, oh, this looks like rainbow method time, or OI, outer and inner. I think I kept calling it last. I'm sorry. It's not last. Last are these two. So outer and inner is a good way to kind of see what your eyes are going to be. All right. So this next one, oof, we're going to have to do some plugging in. So, oh, cool. They did the plugging in. They reminded us what it is here. So just to be lazy and to try to get this done faster, I'm going to copy this here. And then I'm going to paste it again. But when I highlight this, I'm only going to highlight the A. And then when I highlight this, I'm only going to highlight the E and then replace it with this E. And then from here, the C is going to be here. I recommend putting these in parentheses when you're plugging stuff in. It just makes it a little smoother. Especially because it's telling us that we have to FOIL this before we distribute the 2. And then the C. Oh, shoot. Wait, no. Okay, there we go. That in there. So because I can add in any order, I'm probably going to distribute this negative and just do this outside one. Honestly, just because it's easier. In here, I'm going to have a really long, really complicated one. So I'll do the box method for that. But this one just turns into negative 13 minus I and plus 2 plus 12 I. And then continue the laziness. I'll do, like I said, I'll do that parentheses thing later. So now I can combine my negative 12 with my 2, so that makes negative 11. Negative I plus 12I, that's just 11I. Positive 11I. And so all we're missing right now is doing that FOIL. So let me get that FOIL going for you guys. Negative 3 for I. This is 8, negative 8I. Oh, so this makes it easy because it's 8 and 8. The only differences are the pluses and minuses. So this ends up being 8 times 3 is negative 24. This is positive 24I. This one's going to be negative 32, negative 32I. This one's going to be positive 32I squared, which ends up making it negative 32. So what I can do here is I can make this negative 24 plus 24I minus 32I plus 32I squared. So in the next step, I can combine my, wait a minute, something's missing here. Oh yeah, I can combine these two in the middle. So that's just going to be negative 8. Not forgetting that I have this negative 24 in the front, and this turns into negative 32. So the very next step, I'm going to combine these two, so that makes it 56. Now I can finally distribute. I really recommend copying and pasting when you guys are doing this. It just makes it so much easier. So when I distribute this, this becomes 112i. I'm just doing this in my head, but you guys are free to use a calculator when you guys have this on a test. 2, that makes this negative 16i squared. So on the very next line, I get 16 minus 112i minus 11 plus 11i. And then the very last line, I add these two together, 27, and that makes it minus 101i, 101i. Hopefully I did all that. Oh, and of course, I really hate how Momentum does this to you guys. They don't care about all this work I just did. They only care about the answer. What's that? 21, 1. Was it 21 or 26? Great. Please tell me someone screen captured that. Well, must enter and answer. So I did all that work, and apparently I forgot that all of these canceled out somehow. I don't know how. Oh, they regrouped them. I don't know how I messed up on that 5. Did anyone catch how I messed up on that 5? Looks like I missed something. Well, there's your answer. And unfortunately, Admentum only cares about this, which I hate personally. They only care about your right answer. They don't care about all the work. When you're doing this for the activity, please show your work, because if you get it wrong, I at least know what steps you did. And also, if you don't show your work, I tend to mark you down a little bit because I don't know if you just got the answer somewhere else and you're just like, this is my answer. So when I'm doing this, I'm going to pull out the I. So this becomes negative 3i, because I'm pulling out that I. And it's going to be times the square root of 81. In case you guys don't know, is 9. So I get that. And then over here, I'm going to get, what do I have here? I get negative 5. I'm going to take out that I. I'm adding it this time. This one, when you see these square root touching each other, that's multiplication. That's how come you see me putting in parentheses, because I'm multiplying it. And that's how come the I is touching that right there. And square root of 3, or square root of 9 is 3, so this is 3i plus 9i. Our next step here would be to do negative 27i, because we're multiplying it, distributing it out into this negative 5 plus 3i. You know what? I just realized I'm typing all of this in, and then it's going to make me just do the answer again. Oh well. I'm sorry. I meant for there to be more time in class, but I know we're running out of time. So I'm just going to take the hit and do this, and I'll explain the steps. Please don't do what I'm doing. You guys do have the time and the luxury to do it. I'm on the clock right now, unfortunately. So you'll see here that they did what I did, except in way more steps, I feel like it. And then they distribute this, so they'll get that. The negative and negative makes a positive. This would make this negative, but this I squared just turns into a -1, which would turn this into positive 81. So they just move that positive to the front, and then you can combine these two together. They put parentheses. The parentheses is more there to just show you guys, hey, look, they can't really underline when they're typing. So they're like, these two can be added together. All right, and then our answers for here, well, guess the cat's out of the bag, is this idea that what plus 4 gives me 7? What x plus 4 gives me 7? Well, 3 plus 4 gives me 7. What take away, or what plus 6 gives me -2? -8, because -8 plus 6 gives me -2. What plus 8, because remember, we're distributing it, so this is plus 8. So what plus 8 gives me 8, or 5, sorry. What plus 8 gives me this 5? Oh, that's -3. -3 plus 8 gives me +5. And what take away 9 gives me, or take away 11 gives me 9? What take away 11, because we distributed, gives me 9? That's 20. And then they show the work here, but they show it in a complex way. I like thinking of it this way. Put a little box, put a plus 4 equals 7. And then you put a little box, box I, plus 6 gives you -2. So you're kind of asking yourself, what? So that's where I got this -8 from. They solve it a little differently. They're like, hey, let's just put this as x plus 4 equals 7, which I guess works too. That gives you x equals 3, and then y plus 6 equals -I. They're just literally taking these numbers right here. This is another way I like doing it and solving it as two equations. So this equation is, this yellow equation is this plus that. So that's another way of solving it. And then do your self-evaluation. So in this one, I would put, I hate how Edmentum doesn't care about the work. It only wants the answers. And then looking at this, summary time. So the summary, again, always watch these videos. They really help when you're getting ready for the mastery tests. If you guys don't like watching the videos or anything like that, well, I already feel sad because I'm putting all these YouTube videos out. But the way I recommend it, and I recommend everybody that comes to tutoring, take the practice like a bunch of times just to show you why that's important. If I look at this first practice problem, and I look at the first problem on the mastery test, they're very, very similar. This is a mastery test, and this is a practice. The only thing that's different are the numbers. If I were to hit submit, it shows me the work. You can learn by doing the practice. So if you guys are behind, this is a good way of learning, is just taking the practice over and over and over again and studying what this means. So if you guys like learning by doing, that's a great way of doing it. And guess what? The practice doesn't count against you. You could get like 0 on the practice like 100 times and it won't count against you. And meanwhile, you're taking notes and you're understanding how to do it. So let me stop and save the recording.